Hello, it's Simon. I'm doing this for the chemistry summative, and my topic is number 16. Ammonia, the most important commercial compound of nitrogen, is being produced by the Haber process. Fritz Haber was awarded the Nobel Prize in 1918 for this work. So let's start with what ammonia is. It's a polyatomic molecule, and its formula is NH3, meaning it has one nitrogen atom and 3 hydrogen atoms. The bonds between these two atoms have electronegativity difference of 0.484, meaning it has polar covalent bonds and is a polar molecule. I know it's a polar molecule because, judging by its shape, a trigonal pyramid shape, you can see the nitrogen would obviously be the negative, and the hydrogens will form the positive. It's usually found in the form of a colorless gas, with a pungent odor, which is spicy technically. This compound is rather hazardous. First, it's flammable. Second, it's corrosive. If it gets on the human body, it will react with moisture on your skin, your eyes, your lungs, and form ammonium hydroxide, which is really bad for your cells. So as the topic description mentioned, ammonia is the most important compound of nitrogen. When it's used industrially, it's also known as androgynous ammonia, which emphasizes the lack of water in its structure, and it's also hygroscopic, which means it readily absorbs water. This compound has many applications. To start off, it's used in the agriculture industry for the production of fertilizers. It's also used in the production of chemical compounds like nitric acid and sodium bicarbonate. It's used for explosive because it's used to make ammonium nitrate. It's also used for refrigeration purposes like making fridges and air conditioners. It's made for the synthesis of pharmaceuticals, mainly the ones that inhibit bacterial growth. It's used in the wood industry. It helps turn wood into paper pulp, and it's also one of the chemicals that are used as a final covering for the paper. It's used for mining industries. It helps in zinc and nickel extractions. And finally, it's also used in cleaning products, which is basically ammonia in a solution of water. And if you want something more current, the water treatment facilities in Canada, they sometimes add ammonia into drinking water along with chlorine to form a compound called chloramine, which acts as a disinfectant for the water. There's a lot more, but that's all I'll cover for now. Since ammonia has so many uses, that means you need a lot of it, right? So you need a method that makes all of this ammonia, right? So for ammonia, this process is called the Haber-Bosch process. I'll refer to it as Haber process for short. It was invented by a German chemist called Fritz Haber in 1909. At that time, his design was rather inefficient. It could only make a cup of liquid ammonia every 7 hours or so. But after that, a man named Karl Boyce perfected that process for mass production in 1931. That updated process is still being used today, with some variations, but overall the same idea. So, 2 reactants are needed for making ammonia: nitrogen and hydrogen. Technically speaking, getting these 2 reactants is the most complicated part of the process. The actual synthesis of the ammonia is relatively simple. So nitrogen can be easily gotten since air is like 78% nitrogen. They use machines to pressurize air into a liquid, and since gases turn into liquids at different temperatures, they can capture the exact element that they want. They can distill it from the air. As for the hydrogen, it's a bit more complicated. For industrial use, they follow a number of steps to get this gas. First, they'll take a natural gas like methane and react it with steam. I think it's called a water shift reaction. This will produce hydrogen gas and carbon monoxide. Then, they'll take these products and turn the carbon monoxide into dioxide by adding more steam and using an iron oxide catalyst. Then, the carbon dioxide is removed using a strong base like sodium hydroxide, and this will leave hydrogen gas. So now you know how these 2 reactants are gotten. The next part is the actual synthesis of the ammonia. The workers would take these 2 gases and introduce them to a reactor, a ratio of 3 volumes of hydrogen to 1 volume of nitrogen. These 2 in the compressor in here. This reactor will be calibrated to have the following conditions: 500 degrees Celsius, a pressure of 200 atm. ATM is a measurement for atmospheric pressure. So basically, inside the reactor, you would have the air pressure of 200 atmospheres. And lastly, an iron-based catalyst to speed up the reaction. So the formation of ammonia in the reactor is an exothermic reaction, meaning it generates energy. And also should be noted, these two gases react to form ammonia. The ammonia itself can actually decompose back to hydrogen and nitrogen. So the idea is to make the ammonia faster than it decomposes. So after a certain period of time, the two gases are removed from the reactor and put into a holding tank. The gases are cooled and the ammonia gas becomes liquid. And since ammonia has a higher cooling point, it becomes liquid while the hydrogen and nitrogen are removed, funneled back into the reactor to be redone again to form more ammonia. So one cycle of this process will produce around 15% percentage yield. But since you can keep funneling back the reactants into the reactor, you can achieve a final yield of up to 98%. And to make things simpler, here's a clip about the Haber process.
This plant makes 800 tons of ammonia every day. That's enough to fertilize 7,000 football fields. It uses a system called the Haber process. The process needs a giant maze of whining machinery and hissing pipes. To make ammonia, they must first make its ingredients, hydrogen and nitrogen. This is where the nitrogen comes from. There's not much to see on the outside, but on the inside, the machinery pressurizes air to separate out nitrogen from all the other gases around us. Inside this tower, the different gases turn into liquids at different temperatures. It's called fractional distillation. Half a kilometre away is a vast furnace. It makes hydrogen from natural gas, methane. Methane has the chemical formula CH4, 1 carbon and 4 hydrogen atoms. They extract the hydrogen by mixing the methane with superheated steam, H2O, at 500 Celsius. The tremendous heat splits up the methane and the water molecules and frees up the hydrogen. What's left over is carbon monoxide. Finally, the nitrogen and hydrogen come side by side down these pipes. The heart of the plant, where ammonia is made. It's called the converter. Just like the experiment in the lab, the converter contains iron for a catalyst. And it's hot. And it's at such high pressure that the metal wall must be made 11 centimetres thick. Outside, enormous steel bolts hold it together. Here's the problem. High pressure and cool temperature would make lots of ammonia, but it would take too long. So they have to heat the reaction up. That makes it go faster, but it also makes the ammonia break down quicker. Somewhere in between, there's an optimum, a temperature and pressure that works best. So the final stage of the plant starts with a compressor. It pressurizes a mixture of nitrogen and hydrogen gas to about 200 times atmospheric pressure. But the compression has another effect. It also forces the temperature of the gases up to about 350 Celsius. That makes the nitrogen and hydrogen gas molecules split up. Inside the converter, a hot iron catalyst is waiting for the nitrogen and hydrogen. They react together at its surface to make ammonia. The reaction also releases heat, keeping the temperature just right for maximum production, about 500 Celsius. But even so, some of the nitrogen and hydrogen is still left over, so the mixture that passes out from the converter isn't pure ammonia. The very last stage chills the mixture's temperature down, so that ammonia condenses out as a liquid. It's drained off from the bottom. Meanwhile, the nitrogen and hydrogen float up to the top and get sent round a loop back to the converter.
So, to make ammonia from the air by the Haber process, air is first liquefied under pressure and the nitrogen separated out by fractional distillation. Hydrogen is extracted from methane at high temperature. The nitrogen and hydrogen are combined to make ammonia. This is done at high temperature and pressure with an ion catalyst.
And that concludes my presentation. Thanks for watching.